Bismillahirrahmanirrahim. I'm your physics teacher, Miss Kiran Shehzadi. Let's start today's lecture. Error. What is error? For example, a person is measuring weight. According to him, weight is 4 kg. His measured value is 4 kg, but actual value or true value is 5 kg. So there is difference between actual value and measured value, and this difference is error. Errors may be divided into three types: personal error, systematic error, and random error. Personal error. Personal error occurs due to negligence or inexperience of a person. If a person is inexperienced and he is not having proper knowledge, so error may occur. Systematic error. Systematic error refers to an effect that influences all measurements of a particular quantity equally. It produces a continuous difference in readings. If a instrument is faulty, so it will give a continuous difference in readings. Random error. Random error is said to occur when repeated measurements of a quantity give different values under the same conditions. Now we will discuss the causes of these errors and how can we reduce these errors. Cause of personal error is blunders resulting from mistakes in procedure, computational or calculational errors after the experiment. Maybe a person is inexperienced and not following the correct procedure, or he is doing wrong calculations. So, due to this, error may occur in measured value. How can we reduce the personal error? It can be minimized by taking precautions and practice. You must be careful. So, by having the proper knowledge and doing practice, personal error may reduce. Systematic error. It may occur due to zero error of the instrument, poor calibration of instruments, or incorrect marking, etc. Suppose that you are measuring the voltage and your measured value is 4 volt, but you know that actual value is 5 volt. So this error is due to the system, due to the instrument. Maybe the needle of voltmeter is not fixed properly. How can we reduce systematic error? Systematic error can be reduced by comparing the instrument with another, which is to be more accurate. Thus, for systematic error, a correction factor can be applied. Random error. It is due to some unknown causes or reasons because its cause is not fixed. It may be due to any variation in any parameter of the physical conditions, due to temperature, pressure, humidity, or other unknown causes. How can we reduce random error? We can reduce random errors by repeating the measurement several times, and taking an average can reduce the effect of random errors. Uncertainty. Uncertainty means the range of possible values within which the true value of the measurement lies. According to the definition, the uncertainty may occur due to limitation of an instrument, natural variations of the object being measured, or natural imperfections of a person's senses. However, the uncertainty is also usually described as an error in a measurement. Rounding off numbers. One thing you should know that rounding numbers applies to decimal numbers and not to integers. Rounding numbers means shortening the number of digit to the right of the decimal point to make the number easier to work with. The numbers to the right of the decimal point usually show small amount, and sometimes it's okay to ignore very small amounts. While deleting the figures, the last significant figure to be retained is rounded off, for which the following rules are followed. If the first digit dropped is less than 5, the last digit retained should remain unchanged. For example, 40.62 is rounded off as 40.6 because dropping digit is 2 and 2 is less than 5. So we don't change 6. According to the rule, dropping digit is less than 5. So the last digit, which is 6 in this case, remain unchanged. So in this condition, 40.62 is rounded off as 40.6. If the first digit dropped is more than 5, the digit to be retained is increased by 1. For example, 35.429 is rounded off as 35.43. Here the dropping digit is 9 and 9 is greater than 5. So the retained digit, which is 2 in this case, is increased by 1. So we get 35.43 because we add 1 in retained digit when the dropping digit is more than 5. If the digit to be dropped is 5, the previous digit which is to be retained is increased by 1 if it is odd and retained as such if it is even. 43.75 is rounded off as 43.8 because in 43.75 dropping digit is 5 and retained digit is odd number. So we add 1 in retained digit. In 64.350 dropping digit is 5 and retained digit is 3. Because 3 is odd number, so it is increased by 1 and we get 64.4. In 73.650 dropping digit is 5 and retained digit is 6 because 6 is even number, so it is unchanged, and 73.650 is rounded off as 73.6. If the digit to be dropped is 5, then the following situation may occur. There exist zeros after the dropping 5. For example, 32.33500 or 12.345. In such cases, the digit 5 will be dropped and the previous digit, which is to be retained, is increased by 1 if it is odd and retained as such if it is even. In 12.345, 5 is dropping digit and 4 is to be retained because 4 is even number, so it is unchanged, and 12.345 is rounded off as 12.34. In 32.33500 dropping digit is 5 and 3 is to be retained because 3 is odd number, so it is increased by 1. So 32.33500 is rounded off as 32.34. Second case is when there exists a non-zeros digit at any place after the dropping 5. For example, 26.34501 or 44.33567. In such cases, the digit 5 will be dropped and whatever the previous digit which is to be retained is increased by 1, whether it is even or odd in both cases. Here in 26.34501 dropping digit is 5 and there exists non-zeros digit after 5, that is 01. 4 is to be retained, so it is increased by 1 and 26.34501 is rounded off as 26.35. In 44.33567 dropping digit is 5 and there exists non-zeros digit after 5, that is 67, and retained digit is 3, so it is increased by 1 and 44.33567 is rounded off as 44.34. Thank you. Take care.